Hello everyone, my name is Prithul, and in this video I'm going to show you how you can make a semi-dynamic destruction system in Unity. So what I mean is, let's say you have this statue in front of you, and if you click on a body part of the statue, let's say this hand, it will be destroyed, but the whole thing is not going to be destroyed once. In fact, we can actually target what part of this object we're going to destroy. So in this case, let's say it's the hands. So if I click here, as you can see, only the hand got destroyed and the rest of it is intact, and also destroy the head. And if I destroy it in such a manner so that there's no connection between this part and the rest of the body, it will fall off. Anyway, so I guess you get the idea. So let's get started. Okay, so now we are in Blender, and I've imported the model that we would be using in our destruction system. And this model I got from the Unity Asset Store. You can obviously use any model you want. This is in FBX format. I've also deleted the camera, armature, lighting, those kind of scene objects from the scene collection. So what we're going to do is to fracture this object into small pieces. And to do that, right click on this object to select it, go to Object, then to Quick Effects, and then to Cell Fracture. These are the settings that I've been using. The most important setting in this case is the margin, which I've set to 0. Otherwise, there will be like small gaps between your fractured pieces. You can obviously experiment with other settings, or you can just copy them over from this window. And now I'm going to press OK, which will start the fracturing process. And it shouldn't take too long. And there you have it. The fracturing has been done. The first object that you see in this hierarchy is the original unfractured model. I'm going to delete this, and now we'll be left with all the pieces that we want our game object to be destroyed into. So in this case, I have 106 of them. So once we're done with that, we can export it into a FBX model again. So go to File, Export FBX. I've only selected mesh here, and we don't need the animation, so I've also unchecked bake animation. I'm not going to export it because I already have it in my project. However, what you would be doing is just name it something and export it into your Unity project's asset folder, and click Export FBX here. Okay, so we are back in Unity, and I've got a new empty scene. The first thing we're going to do is create a 3D object plane and reset its position to the origin. Next, we are going to import the fractured mesh that we just created in Blender, and I've got it in here. Obviously, your location is going to vary depending on where you exported it to. So for me, actually, this is not the one. Let me see. So yeah, so this is the model. For me, I'm going to reset its position, and also you can see that it couldn't find the material. So I'm going to select all of the child of my mesh and go to Mesh Renderer, go under Materials to Element 0, and find the material. So where is it? Let's see. So I think it's this one, or it could be this one. I'm not quite sure. Okay, let's see how it looks. Well, it, in fact, is this one. Great. So we've got the material. However, as you can see, the model is not quite upright. So let's rotate it. That looks about correct. Yep. However, the lighting is kind of off, so we'll also change the direction of the light. That looks about right. So now we've got the model and the basic scene going. So let's get into coding. But before that, we need to get a basic idea about how this whole system is going to work.
So I'm in Photoshop and in front of me is a picture of a plane. I'm going to explain the process with a 2D picture. However, the same is going to be true if you use a 3D model. The lines here you see are basically representing the fracture lines, which is similar to what you'd get if you did the cell fracture process inside Blender on a 3D mesh. I've also numbered each of these pieces starting from 1 up to 21. What we want to do is somehow represent this whole fractured model inside our code as a connectivity graph. Now, why we want to do that? Let's say we know that each of this node, they're connected to some other nodes. So for example, node number 2 is connected to 1, 4, and 3. And node number 5 is connected to 4 and 6, and so on and so forth for every other node in this object. If we know that, we can also find if a node is connected to some other node through some path. So what I mean is that let's say here we've got node number 5 and node number 20. There is a connection between 5 and 20, obviously not directly, but indirectly through 5, 6, 8, 14, and 20, which means that this this node and this node are connected somehow. However, if I let me get the eraser. Okay, so if I delete node 6, okay, so if I delete node 6, there's no path between 5 and 20. And so we know that this piece and this whole piece are two different objects here. However, if I deleted 1, there would still be a connection from 5 to 21. And if we have a graph, we can apply some kind of graph traversal technique. For example, breadth first search to find if there's a path between one node and another node. And in that way, we can decide what to do with our mesh when we want to destroy a part of the object. So that is a very high level idea of how it's going to work. And now I will get to the code where I hope this will become much more clear. So let's go back to Unity. Okay, so I'm back in Unity. And as before, I've got the fractured model in front of me. So I'm going to now show you how the coding part of this destruction system works. However, I'm not going to code it live because, well, that is going to take way too long, and also it's going to be very error prone. Instead, I'm going to go through the code and explain how it's working. So here we've got two scripts, the destroyed piece controller and destructible object controller. For any fractured mesh that we get from Blender, obviously it has to have a parent, and underneath it, it will have all of the fractured pieces like we've got here. For any such mesh, what we want to do is drag and drop the destructible object controller in the inspector. And here you can see we've got one game object reference field, and it's named root. So what this root is basically a a piece in the fractured model that connects the whole mesh to the rest of the game world. So for the new fractured model, let's say there are many pieces here and mesh 070 here. This actually touches the ground, so we can select this as a root game object. And this is also going to come in handy when we want to apply breadth first search in our graph later in the code. So let's drag this particular game object into this field. And that's basically the setup you need to do to enable semi-dynamic destruction in your game. Now I'll go to the code and explain how the code is working. Okay, so here we are in the code of the destructible object controller script. First, we've got the root game object that we just saw in Unity. Next, we have a destroyed piece controller variable. This is the other script that I'll explain later in the tutorial. The basic idea is that every fracture piece will have a destroyed piece controller script attached to it. And this particular variable, the root destruction piece, is basically the destroyed piece controller that we'll get from the root game object. Next, we have got a list which is named destroyed pieces. This is a list of all of the fracture pieces that is underneath the parent game object. So if we go back to Unity, this was the parent of our model, they fractured. So all of these pieces, starting from this to the last one, all of these pieces will have the destroyed piece controller script attached to them. And here we're basically getting a list of reference to all of those scripts. Next, there's the awake function. In this function, we are basically iterating through all of the pieces and attaching to them the destroyed piece controller, a rigid body, and a mesh collider. So this is done so that we don't have to do this manually before when we are setting up the scene. This can get, if you have a lot of destructible objects in your scene, this can get very tiring. So instead we are doing it in the awake function right when the game starts. So we go through all of the children of our transform, and for each of the pieces, we'll attach a destroyed piece controller. We'll attach a rigid body. We're initially going to make it not kinematic, so it is set to false. Also, the gravity is set to false. We're also going to attach a mesh collider, and we're going to make it convex. And finally, we are going to add the destroyed piece controller variable to the list that we had here. So this is going to happen for every piece. And after this is done, in the destroyed piece list, we'll have reference to all of the destroyed piece controllers underneath the parent. And finally, we are getting a reference from the root game object that we just assigned in the inspector and storing it in root dist piece variable. Once we are done with this, we will have something that looks like, okay, so if I play this, just give it a moment. Okay, so where's the scene? So here's the scene, and once we're done with this section, it will look like this. So every piece under the parent will have a destroyed piece controller, a rigid body, and a mesh collider. Okay. So going back to the code, the last line here you see is a coroutine that will run the physics for 10 steps. I've just arbitrarily selected 10 here. You can experiment with different values. However, what it is doing is, if we go to the code here, it is waiting for fixed update for 10 iterations. So it will wait for 10 fixed updates. And once that is done, it is going to do something with each of the fractured pieces. And what we are doing here, I'll explain later. And that is that is somewhat linked to the other script, which was destroyed piece controller script. So once I've explained that, I'll come back to this. Next, we have the update function. This is also something that I'll be explaining later, as well as the find all connected pieces. Okay, so now we'll look what's happening in the other script, which was the destroyed piece controller. So in this script, there is a public variable which is connected. This basically tells us whether this particular fracture piece is connected to the rest of the mesh. There's another variable called visited. This will be useful when we do the breadth first search. And there's a list called connected to. This is going to hold all of the neighbors of this particular fractured piece. Then there's a static variable called is dirty, which we will have a look later. Then there's some references. The first one is the rigid body component of this fractured piece. Next, there are three variables: the starting position, starting orientation, and starting scale. These are the values that we get from the transform of the object. Uh, these are basically, how can I explain this? Okay, so these are basically the initial position, orientation, and scale of the fractured pieces. And we are going to need them later once we have run the 10 physics steps that I just showed you. So if we go back to the run physics steps function, excuse me, the run physics steps coroutine, once we have run through 10 physics steps, we are doing something here, which I said I'll explain later. Basically, what this is doing is restoring the initial position, orientation, and scale of each of the fracture pieces. And that's why to do that, we need to store the initial values before we enable physics in our game. Next, there are two private variables configured and connections found. I'll go to them later when we need them. So if we go to the start function, in the start function, we create the list because we are going to find out uh, what are the pieces that are connected to this piece. Then there is the starting position, starting orientation, and starting scale. We are going to get the current values for each of the position, rotation, and local scale values and store them in there. And finally, there's the rigid body reference that we uh, defined here. Not defined. What's the correct word? Uh, Declared here, right? Which we declared here. So we get the rigid body component here and store it here. Now, one important thing is that this is in the start function uh, as opposed to awake function. That is because before the awake function runs, there is no rigid body component attached to it because we are creating and attaching the rigid body in the awake of the parent. So we are doing everything here in the start. Okay, so that's basically what will happen once we play the game. However, we still don't have the connected to list filled with all of the pieces that are connected to this game object, uh, to this fracture piece game object. And the way we are doing it is using the Unity's physics system, and more specifically, the onCollision enter function. So once we play the game, what's going to happen is this script, the destructible object controller script, is going to attach um, the destroyed piece controller script to each of these objects, and that will cause them to have a rigid body, a mesh collider, and obviously the destroyed piece controller script itself. Again, so if I do that, Just hold on a minute. Okay, there you go. So again, once we play the game, this scripts and components has been attached to each of these pieces. And now since the game is running, what we are going to do is for the first 10 frames, we are going to let the game run by itself. And since each of the pieces have a rigid body and mesh collider attached to them, they're going to collide with their neighbors. So uh, let's say for 71, actually that's going to be hard to visualize. So instead, let's select one of these pieces. Okay, so let's say for piece 5, it is connected to this piece, this one, and maybe some other pieces as well. And when we run the simulation, there's going to be collisions happening because of the physics that we have enabled, and that collisions are going to be registered in the uncollision enter method. And if we look inside the collision object here, we can actually find out which of the game objects this game object is colliding with. And that way we can know what each of these fractured pieces are connected to. So what we are doing is first getting a reference to the destroyed piece controller from the collision game object that we just collided with. And if this is not null, that is, it did collide uh, with a fractured piece that had a destroyed piece controller script attached to it, we are going to first see if this neighbor has been already added to the connected to list. If not, we're going to add it to the list. Again, this is only going to happen for the first 10 physics frame. And once we are done with that, this configured flag will be set to true. And no matter how many times uh, a destroyed piece controller collides with another one, this is not going to trigger. This is not going to get triggered. And if that doesn't happen, which means if the configure flag is not false, that is after the first 10 physics frame, we're checking if there was if the collision happened with the floor in the scene. And if that is the case, we're spawning a dust cloud. So this is basically just a visual effect. So that is the uncollision enter method. Now going back to the run physics step function, coroutine, in fact, as you can see, after we wait for 10 physics updates, we are calling the make static function on each of the pieces, each of the fractured pieces. And what this make static function does is that first it sets the configured value to true so that the on collision enter, inside the on collision enter, these lines of code will not be triggered anymore. We're also going to set the rigid body to kinematic. So basically all of the pieces are going to be fixed in place. We're also going to set gravity to true, because obviously we want gravity in your game. When we hit the mesh, the pieces that fall off should fall to the ground. And finally, we're going to restore the local scale, position, and rotation values that from the values that we stored earlier. And the reason that we have to restore these values is that because the physics was running for 10 steps, there's a very high possibility that the pieces would have changed positions and rotations. Not necessarily the scale, however, we can increase the scale in the beginning. Not here, but let's go to this script. We can actually change the scale when we add the rigid body, maybe, so that the pieces become bigger and there's a high probability of not missing its neighbors, so that the collisions do happen more reliably. However, in my example, I believe I haven't changed the scale, so this is kind of redundant. So back to the destructible object controller script, the update function and the final connected pieces function. These two are the functions that enable the dynamic destruction. So when we want to, let's say, destroy a part of the mesh, what we are going to do is call the cause damage function of a particular piece. Then there's the cause damage function in the script. And what it does is basically, when called, it will say that it will set the is connected variable to false. So this piece is not going to be connected to the rest of the mesh anymore. We're also going to set the is kinematic value to false so that it can fall off. There is a static variable is dirty that is shared between all of the instances of the destroyed piece controller script. So that's why it's static. We're going to set it to true. And this flag will be used by the destructible object controller to update the state of the mesh. And finally, we're going to add a force, which is going to be in the direction of the vector of the 3D vector force, and will also have the same value. And it's going to be an impulse force. And finally, we're using another script, VFX Controller, that I'll show you later, to spawn a dust cloud in the position of this piece. And finally, we have this drop function, which we will call from the destructible object controller script. This is called after we have done a breadth first search and we have decided that some pieces need to be detached from the mesh. And this does the same thing as this, except for the dust cloud spawning thing and applying a force. So back in the destructible object controller script, we are first going to check if the isDirty flag was set to false, and this is going to be set to, if the isDirty flag was set to true, and this will be set to true in the cause damage function. The cause damage function is something we call when we decide that one of the pieces needs to be detached from the mesh. So let's say we have a gun in the game and we shoot at the mesh, and we decide that this particular fracture piece is going to be affected by the bullet. So we'll call the cause damage function, and this is going to set the isDirty flag to true. So if we find that the isDirty flag has been set to true, first we are going to set the visited flag of all of the destroyed, all of the fracture pieces to false. This is just a standard procedure before running a breadth first search. Next, we will run a breadth first search algorithm here, which is defined here. Once we run this, and we'll start from the root game object that we assign in the inspector at the very beginning. Once we run this, all of the fracture pieces that could be reached from the root will have their visited flag set to true. So only the pieces that couldn't be reached from the root will still have their visited flag set to false. Once we're done with that, we'll run another loop, and this time we're basically checking if the visited flag is set to false. If it's set to false, that means we couldn't reach it from the root, and so we are going to call the drop function of that piece. And what the drop function does is something we've already seen, which is it sets the is connected to false, and the rigid body is kinematic to false. So the piece will just fall off the mesh. And in the find all connected pieces function, which is the breadth first search algorithm, we are basically just seeing if a particular piece has been visited. If it's not been visited, we are also checking whether it is connected to the mesh, because if it's not connected, we don't really care about it. Then we're going to set its visibility, we're going to set the visited flag to true. And finally, for all of the connected pieces, all of the pieces that's connected to this piece, we're going to call the same function. So it's going to recursively find all of the pieces that can be reached from the root. So back in Unity, we have another script, which is the VFX Controller Script that I made. And this script is basically just used to spawn different VFX effects as prefabs. So right now there's just one function, which is the spawn dust cloud function. And if I do the instantiate, if I call this function, it will instantiate a dust cloud prefab in the scene at this position. And this is exactly the function that we are calling from the cause damage function of the destroyed piece controller script. So in Unity, let's create a new empty game object and maybe name it VFX controller. And we're going to attach the VFX controller script to it. And the prefab that I'm going to use, which is a particle emitter, is named smoke variant, I think. Yep, that's the one. So that's that. And finally, we need another game object, which we can say, let's just say maybe. And we'll use the final script, which is demo controller. Yep. We'll attach this script to the demo manager game object. And what it's going to do is basically get our mouse position, create a ray from it. When we press the mouse button, it will cast a ray and see if we hit our mesh, and if it did, it will get the destroyed piece controller component from the piece and call the cause damage function. So so now we should have everything that we need, and let's see where the camera is set. I'd actually like to have the camera somewhere around here. Okay, so that looks about right. Okay, so the final thing that's remaining is to change the layer of our mesh. So let's go to the layers and move it to the destructible layer. And yes, we want to change the children as well. So once you're done with that, we can play the game and see if it works. And as you can see, well, it does work. There you go. Thank you for watching. I hope you enjoyed this video and learned something new. If you have any questions about this, you can write it down in the comment section and I will try to answer them. There are many more improvements that you can make to this system. If you come up with some new cool idea, please let me know. I'd be glad to hear it out. Thanks again. I'll try to come up with a new tutorial video sometime in the future. Thank you.